So far, we have been building our cloud environment step by step using Azure and Terraform, and everything looks perfect. But in real life, things don't always go as planned. A virtual machine can fail, data can be lost, and sometimes the infrastructure already exists before automation even begins. In this video, we are going to solve these challenges. We'll learn how to protect our virtual machines using Azure Backup and how bring existing resources under control with Terraform Import. Let's quickly review how our project has evolved so far. On the Terraform side, we moved from a simple single file setup to a more structured and scalable architecture using modules, remote state, and governance controls. On the Azure side, we built a core infrastructure step by step, from resource group and networking to virtual machines and security improvements. Now in this part, we continue this evolution by introducing Terraform Import to manage existing resources and Azure Backup to protect our virtual machines. In real cloud environments, protecting workloads is just as important as building them. Azure Backup is a fully managed cloud backup service that helps us protect virtual machines and other workloads in a secure, scalable, and automated way. Backup operations are defined using a backup policy, which controls when backups are performed and how long the data is retained. Unlike the traditional model, Azure Backup in this architecture focuses on disk level protection. During the backup process, Azure creates snapshots of the managed disks and stores them securely using the Backup Vault. This allows us to restore data efficiently, whether it's recovering a disk or restoring data to a previous point in time. In the newer Azure Backup architecture, the core component is the Backup Vault. The Vault acts as a central place where backup configurations, policies, and protected resources are managed. Now that we understand how the new Azure Backup model works, let's move to the Azure portal and create the foundational component, the Backup Vault, which we will later manage using Terraform. In the search box, we type Backup Vault. Then we hit the create. Next, choose the subscription and select the resource group that our resource group is RG Linux VM demo. You can either create a new resource group or using an existing one. Provide a unique vault name, like let me check what do we need to use, because we're gonna import these backup vaults to our code using Terraform Import. So I'm gonna use the RSV demo existing, and also it's recommended to choose the same region as your virtual machines for the better performance. So after reviewing the configuration, click review and create, and then we can create it. Once deployment is completed, the Backup Vault will be ready to manage backup policies and protecting resources. And it says validation phase is not valid. Why? Let me check it. Let me go and create it again. I don't know what has happened. So I think we didn't choose it. I'm gonna use the local redundant. It's a demo. It doesn't matter for us for now. And review and create. Okay, it was my best. Sorry. Alright, now that we have created our backup vault, let's quickly see how a backup job is normally configured in Azure portal. I'm not going to complete everything here because later in the video we will automate this entire process using Terraform. So inside the backup vault, you can go to backup instances. So if I hit the backup here, it's gonna ask you about the name. It shows the RSV demo existing. So it's gonna ask you about the backup policy. So when I create new, I'm gonna use the unique name like this backup policy, that I'm gonna use it as a Terraform code in the next part. We could create a new policy here, or we can use the existing one. But for now, I just wanted to show you the overflow. So I'm gonna create a backup policy for here. And after that, I'm gonna delete it, don't worry. So we can add the object to create. For example, now we have a disk here of our virtual machines that I have created before recording the video. So I'm gonna choose it and select, and after creating this backup job, it's gonna take a backup of the disk of virtual machine. I'm not gonna do that now because I want to do it by Terraform code, not visually on the Azure portal. Azure Backup in this model is based on disk level protection, not the entire VM directly. After selecting the disk, normally we would configure and enable the backup instance. Azure would then start creating recovery points based on the back policy schedule. But instead of finishing this configuration manually, we will stop here because, as I said, our goal is to define this entire process using Terraform in a consistent and repeatable way. So now that you've seen how the process works in the portal, let's move to the next topic and learn about Terraform imports. Let's say you join in a company and everything is already running in Azure. Virtual machines, networks, and all created manually. Now your job is bring everything into Terraform, but you can't recreate anything. So what do? That's where Terraform Import comes in. Terraform Import allows us to take existing resources and bring them into Terraform state without rebuilding them. So instead of creating new infrastructure, we start managing what already exists. This is important because in real environments, most resources are not created using Terraform from day one. By importing them, we can integrate everything into infrastructure as code. That means consistent deployment, better automation, and easier management. It also helps us avoid recreating resources which can cause downtime and reduces configuration drift by keeping Azure and Terraform in sync. So instead of rebuilding everything, we bring existing resources under control. Alright, now let's move to the next step and look at our Terraform project structure and starting building this in code. As I mentioned before, we already have a virtual machine and a backup vault in our Azure environment. So in this part, we are not creating them from scratch. Instead, we'll use Terraform Import to bring them into our configuration and start managing them using infrastructure as code. For the backup step, we already prepared everything inside modules. We have one module for the backup policy and another one to enable the backup. So after importing resources, we'll use these modules to configure and enable backup. Let's move to VS Code, check the code briefly, and then we're gonna run it and finally verify the result in Azure. Alright, let's go through the code quickly. As I mentioned, we already have a virtual machine and a backup vault in Azure, so we are not creating them from scratch. First, we use Terraform Import. So to bring existing backup vault into our configuration. So here we are telling Terraform this vault already exists, just start managing it. Next, for the virtual machine and its disk, we are not importing them. We are just reading them using data source, and you can see we are using data sources here for the virtual machine and disk. This gives us the information we need without touching the existing resources. Then we define backup vault using the new model, as you can see here. And also you can find all of this Terraform code on my GitHub repository from this part and all of the part that I have recorded. So the important part here is that manage identity, because Azure Backup needs permission to access the disk and create snapshots. And then we enable backup using the second module. Let me bring it up. So this is where we actually connect everything together and enable backup for the disk. So the overall flow is import the existing vault, then read the existing VM and disk, and define the backup policy, and finally enable backup using modules. So now let's run the code and verify the result in Azure. So let's run it and see what happens. I'll pause the video while it runs, and then we'll come back and check the result in Azure. So there it says it already exists. So I delete it and I'm gonna run it again. So as you can see, it's gonna create two resources here. One of them is backup policy and one of them is gonna enable the backup policy on the disk, instance disk from the virtual machine. So I'm gonna apply it and then we'll see the results on Azure. So it's done. Let's go to Azure portal and check the results. So I'll open Backup Vaults. Let's start with this is our Backup Vault. Let's start with backup instances. Here we should be able to see our backup instance created by Terraform. You can see the resource will be listed here. So okay, now you can see it, which means the backup has successfully enabled. And if I go to backup policy, here we can see the policy that we define with Terraform. This confirms that our policy configuration has been applied correctly. So if we go back to backup instance, we can also see its status and details, like the associated policy or protected resources, and you can see protection configured. And this is how we enable a backup for example, for a disk of a virtual machine. So instead of configuring this manually in the portal, we were able to define everything using Terraform. And this is the key benefit. We now have a repeatable and consistent setup managed entirely through code. In the next part, we are going to level things up even more. We'll move beyond backup and start working with a high availability in Azure, learning how to design more reliable and production-ready environments. We'll also introduce Terraform provisioners and see how we can automatically configure our virtual machines after deployment. So instead of just creating infrastructure, we'll start making it smarter, more resilient, and more automated. So see you in part 7.